Good day, everybody. My name is Juan León Becerra, and I'm going to present the work entitled Fuse Deposition Modeling Fiber Content Evaluation with Digital Image Treatment Techniques. This work is made possible by my co-authors Jorge Díaz, Alberto Pertús, Octavio González, and María Jaramillo from the Universidad Industrial de Santander and Tecnoparque Nodo Bucaramanga in Colombia. As a brief outline of this presentation, first we have the problem statement, followed by the materials and methods employed, then the results, and finally discussions and conclusions. Additive manufacturing is a recent technology in which a part is created from a CAD file that passes through a slicer software, gets constructed in a layer by layer basis using a 3D printer. So we have here the schematic image of a continuous fiber reinforced fuse filament fabrication machine. We have two spools. This one is for the feed of this extruder, which extrudes thermoplastic polymer matrix, while this other spool extrudes the reinforced filament, which can be in form of carbon fibers, Kevlar, or fiberglass. It is getting deposited in this moving platform, and we can control the path of the reinforcement fibers as well as the volumetric quantity. At the right, we have an image of a Markforged Mark II, which is the 3D printer employed to this research. We have here the matrix filament, which is kept safe from moisture in the air. We have the fiber spool, the double extrusion head, which can move relative to this platform. So if we want to design with this process, we have to know first the mechanical properties as well as the material properties to know the stiffness and strength of a composite additive manufacturing material. Here in this figure, we have the schematic of the fusion process. We have the spool that is fed through the extruder nozzle. We have a cutter which helps into determine the specific length of which the fibers must need to deposit. So in a way to determine the mechanical properties, we need the volumetric fiber content of the part. There are some methods like the GIS-K1775, which define a method to establish the volumetric fiber fraction by burning the whole composite and then weighting again to the remaining residue. This has a problem that is limited to carbon fiber, which has a great fusion temperature. Other methods are thermometrical analysis, and in 2008, Kahn, Adam, and Schneider proposed a method to establish the volumetric fiber fraction by counting the matrix and fiber areas using a scaling factor. So using optical methods and digital image techniques. One of the advantages of knowing the volumetric fiber fraction is to employ methods such as the rule of mixture or the inverse rule of mixture that are based on the volumetric fiber fraction. So this work shows an approach to extract matrix and fiber characteristics in carbon fiber reinforced thermoplastic composite. Calculate the volumetric fraction by using digital image techniques. A digital image can be represented by a matrix in which each position of the matrix represents a pixel, and each value in the position of the matrix represents the brightness of the pixel. Now, segmentation methods assign a group to a pixel called segment. So one of the segmentation methods is the threshold. Here we have the definition of the threshold function, in which takes the value of 0 if it has a specific value of brightness and 1 if it's greater than the threshold. So here we have an image with different gray values, and if the value of the gray is higher than, let's say, 50%, it gets 0, and if not, it gets the brightness of 1, which is white. So here we have the representation of the image and the conversion of the threshold image B. The materials and methods employed were unused Kevlar, carbon, and fiberglass fibers. So these were taken from the manufactured spool. They have a diameter of 0.4 millimeters. We take a bunch and then we perform a metallographic encapsulation from with 60 to 200 grids, and then we analyze them in a scanning electron microscope Vega 3 test scan. So to avoid scaling pixel to millimeter, we take 2 separate fields, and counting operations were made. One for fiber applying the threshold described in equation 1, and equation 2 giving a volumetric fiber fraction. The second process was done for the matrix by tracing matrix perimeter and area inside it was estimated, namely AP, and the volumetric fiber fraction was calculated using the total area of the fibers divided by AP minus AF. We use the image in a Fiji software and 8-bit black and white TIFF file format. This flow diagram represents the segmentation process. First, we read the image, then convert it to grayscale and black and white, then apply the corresponding threshold. We to separate the fiber and matrix regions. So we first draw in the matrix the perimeter, we calculate the overall area, and for the fiber we draw line edges to show the amount of fibers. Then we count the pixels inside each of the boundary and determine the area of the fibers. For the results, we have here a micrograph of an unused carbon fiber bundle. So here we can see some porosities inside the filament, as well as the fiber group in clusters. The histogram showed the gray frequency, so the histogram was useful to determine the appropriate threshold value. This threshold value was useful to determine the perimeter of the spool. And then we use the line edge detection to differentiate between fibers and matrices. Some of the results were inaccurate due to the fiber placed in non-perpendicular to the focal plane. So we can verify the diameter of the carbon fibers, the distribution, and the matrix, but it was difficult to observe the fiber volumetric fraction in images that weren't perpendicular to the focal plane. Conclusions. Image treatment techniques were used to extract fiber and matrix areas to obtain the ratio between them. The ratio is called volumetric fiber content, F, that for the carbon fiber reinforced thermoplastic polymer was around 35%. The proposed method works for continuous fiber reinforced composite. It was tested with a thermoplastic matrix And this method is not recommended to be used in pure fiber reinforced composite because it only analyzes a transversal area instead of the whole volume, potentially leaving out zones with different volumetric fiber fraction. Also, care should be exerted when taking image that and making sure that the area is perpendicular to the lens. Failing to do so may induce erroneous reading as the pixel counting algorithm might count the fiber lateral surface as transversal fiber area. Finally, the picture for fiberglass and Kevlar were inconclusive at the moment of writing this paper. Here are some of the references employed. Thanks for listening, and if you have any question, I'm glad to respond.